Hello and welcome. I'm Peter Nass, an offering manager from Kyndryl, and I'm delighted to introduce you to the Data Center Strikes Back, our new podcast series that explores leading industry trends, customer use cases, and technology solutions in the data center world. In each episode, I'll be joined by experts from Kyndryl and Nokia, two of today's global leaders in technology, innovation, and customer success, as they will share their insights, experience, and unique perspectives on the data center's strategic contribution and its role as critical infrastructure. In our first series, we'll take a look at the realities and relevances of the data center for the enterprise today, and with an eye toward the future. We'll cover the general growth trends, challenges and solutions for data center interconnections, multi-stakeholder investments, as well as quantum-safe networks. Amazing technologies that are set to present enterprises with new ways of thinking to meet the emerging business requirements. So let's get started. In the first episode, we're asking, is the data center finally dead? Okay, maybe that's extreme, but we've come a long way since the data center's origins as a safe bunker housing, legacy mainframes, attached storage, and the like. Fast forwarding to today, there are so many drivers propelling this astounding growth and change in our data center fabrics and the interconnections. Drivers such as, rapid mainstreaming of Gen AI, mass cloud adoption, escalating threats, regulatory requirements, and application repatriation driven by, potential pitfalls from the false cloud economics. In this episode, we'll be discussing the drivers behind this data center growth, enterprise demand for security, business resiliency, and networking at scale, as well as the technology innovations to meet these needs. Joining me for this deep dive session today are James Knights, Principal Architect from Kyndryl Consult, as well as Vittorio Iozzolino, Head of Business Development for Optical Networking from Nokia. Great to have you here, gentlemen.
Thank you.
Thank you for having us.
So why don't I kick things off here talking a bit about market trends. So James, from your perspective, from Kyndryl's perspective, what are some of the current trends that you're seeing out there kind of driving that overall data center growth?
Hi, Peter. Thanks for the intro. I'm happy to be here. But you stole most of the headlines, right? But what's the phrase? Reports of the death have been greatly exaggerated. As enterprise digitize more procedures, services, and trends, the demands increase exponentially for storage, high performance, and low latency. And here is the thing. Because cloud happens at somebody else's data center, you need to move all that data back and forth, right? When you start having ingress and egress of data, you start to lose or erase some of those savings. The same thing happens with the computing power that you need, right? Cloud is great when you need elastic compute power. It is not so great when your needs are constant. And that's where we're seeing a lot of customers trending back to their own prem. And some of the drivers for that, there is a couple. One is Gen AI, as you mentioned. Gen AI requires very high performance computing, right? 400, if not 800 gigabits per second between the nodes. And that's not really something you want to be sending to somebody else's data center, because it can become expensive if you don't control the setup. As well, we have customers that require, for security reasons, for regulatory reasons, that the data remain in country. Then you're stuck. You have to have a data center, right? And I think the last bit of investment we're seeing is that a lot of customers went to software-defined data centers when the technology matured. And now their devices that they bought, the switches, the routers, are now getting to the point that they will be end of life. And so they're looking, what do I do? Do I replace a one for one? Do I modernize and go to a more efficient environment? And that's where we're seeing a lot of investments.
Vittorio, is there something perhaps you can add a little bit as to what you're seeing from your perspective, from Nokia's perspective?
Actually, I fully agree with what James just mentioned. What we see as well is, for example, an increase of the Internet of Things. If you think about Industry 4.0, and this requires, again, an increase of data center capacity, especially close to the factories. Maybe just a couple of other points we see is the green demand in terms of sustainability. So this is also driving the build of a new type of data centers. And so sometimes so closer to the environments where they have to be used, the 0 kilometer. And another point which is worth to mention is the increase of high performance computing. So we talk about quantum computing, and the amount of data that these computers are requesting has to be stored somewhere, actually. And therefore, we do see an increase of data center capacity and amount as well.
So what I'm hearing here, that the data center is still very relevant. Growth is happening. So I think we're kind of going toward an answer toward, is the data center dead? Let's go just maybe a little bit further. So these macro trends are quite interesting, and that's where and what is driving the expansion. But maybe if we can just look a little bit deeper into some of the use cases of that sort of data center interconnect and sort of like the nature of that.
Sure. So let's say when we look at the DCI, so data center interconnect, we especially in the enterprise segment, we have to start from the reasons why the number of these data centers has increased, as we just mentioned before. We have named several causes, and if we look at some of them, so we can identify some triggers that are contributing to the growth and the diversification of these interconnection. So for example, if we look at the cloud and hybrid cloud adoption, I mean, this requires robust, high bandwidth and low latency interconnections between the data centers. This trend, of course, drives the need for sophisticated optical DCI solutions that simply connect on-premises infrastructure with the public cloud environment. Another example, if we look at the digital transformation and at the edge computing, which we mentioned before, we see that the organization are expanding their digital footprint and implementing these edge computing architectures. In this case, this requires flexible optical DCI solution. And this solution have to support distributed computing models, have to enable rapid data transfer between centralized data centers and the edge locations. And of course, they have to provide scalable network infrastructure to support these emerging technologies, like James mentioned, for example, AI before. If we take another example, big data, analytics workload, the interconnection between enterprises and with the data centers must ensure high capacity. So we go from the classical 100 gigabit per second to 600 gigabit per second, and even to 800 gigabit per second. We need low latency. We need reliable data synchronization across the geographically distributed data centers. And of course, we need support for high performance computing as well. If we look at business continuity, disaster recovery, in this case, what enterprises are prioritizing is robust disaster recovery solution, active and active passive data centers configuration, seamless failover capacity, and geographic redundancy. And all of these needs a specific and sophisticated interconnection between the locations. So at the end, what we have is that if we summarize, we have a growth of data centers and interconnection between the data centers. And what the triggers are in terms of technology is the robustness of the connectivity, it's the reliability of the connectivity, is the high bandwidth, is the low latency, is the flexibility of the solution, and then last but not least is the security of the data. That's the encryption.
Yeah, no, that's those are some very strong key points, and they're very relevant. James, is there something you could perhaps like to add on that before we kind of?
Yeah, I'd like to. I think that one of the key items here is the resiliency. So when you look at the way that today's data centers are built or designed, it is designed about applications, right? and each application is owned by a project. But in the end, you have multiple projects responsible for paying the environment, which leads to multiple high-speed connections, right? And then if you have storage, you have multiple storage capacity, and they require FICON and they require fiber channel. When you add it all together, you end up with a requirement for a very high pipe, large throughput, right? Now, what happens? In the past, we had DWDM. You had to make sure that you pre-prepared in case something went wrong and you had an available backup channel. And even then, sometimes it required human intervention to move those lasers around. The technology has advanced so much, the intelligence of the system has advanced so much that today's OTN, an optical transport network, it is like comparing a peregrine falcon with a dinosaur, right? It is fast, it's efficient, it's nimble. And we find that our customers are having a sort of light bulb moment where they go, wow, you mean I can actually, by going through one of these optical systems, connect A to B, all of my data requirements, very high bandwidth, very low latency, and I can do this securely. It is an epiphany for our customers.
This is actually a terrific segue into sort of the last piece I want to bring it home with. And you hit on this, right? The different types of technologies. And Nokia, as a market leader in these technologies, are bringing these things to market.
Yes, sure. So as mentioned, Nokia has been actively innovating in enterprise networking, specifically in data center space. Beside the classical fabric and routing solutions in data center interconnect space, we have developed, let's say, a cutting-edge optical networking technologies. And these address all type of connectivity for enterprises, including the data center specific ones. So we have developed a very advanced coherent optical transport solution. We have increased the bandwidth. So we have said in the past 1 gig, 10 gig, and then we go to 100, even up to 1.2 tera, which is possible today between the two sites on a single wavelength per single chipset. We do support all type of different client interfaces needed today, and then specifically for the data center interfaces, like James mentioned, fiber channel, InfiniBand, and so on. We do use flexible grid optical networking, the so-called flex grid, which means we increase the flexibility in the usage of the fibers, and so the network topology, and the simplification of the design of the network itself. And then, as James mentioned, we have developed adaptive network technologies that can dynamically adjust and change the bandwidth on demands. Let's think, for example, you have a data center and you have a backup session to be done on the weekend. And then suddenly from the NOC, you just say, okay, I need to increase my bandwidth and I want to go from 100 to 600 gig per second. And then in the NOC, you just press a button and then the system is doing automatically. So it's increasing the bandwidth on demand, keeping the rest the same. If needed, is even able to change the modulation used according to the distance and the bandwidth. And then you can have it. And when it's finished, you can put it back as it was before. And this, we can do it because of our own developed DSP, the PSE, so Photonic Service Engine, which is now at its 6th generation. Besides that, we also offer encryption technology. We mentioned before the security topic, which is very important. So we give the possibility to encrypt the traffic directly on the WDOTN systems, so directly at layer 1. And we do it on fly, so basically without adding latency. We can provide as well a comprehensive threat detection and mitigation in case of issues on the network, because we have a so-called wavelength supervision system, which allows you to supervise all single wavelengths and to discover if somebody is tapping the fiber, for example. And in that case, some of the services in the wavelengths will receive an attenuation, and you can detect it. And we can also detect where this is happening through the OTDR systems. Of course, you need to manage these networks, and we have a very good network management system, the so-called WaveSuite NOC. And this can also provide automatic network monitoring so that you can even offer and use advanced predictive maintenance.
Yeah, that's fantastic. Those numbers kind of blow me away. But thank you so much for sharing that. I'm going to kind of wrap up here now.
We've heard about macro market data center growth trends, enterprise-specific use cases, and the need for modernization to support data center growth trends and drivers. With the latest and the greatest in technology innovations, we're in an exceptional place to address these needs and help our customers future-proof their mission-critical networks. Is the data center dead? No. In fact, it's just getting started. But what do you think? Can data centers handle our modernization demands? Are enterprises up to the task? Let us know using the hashtag #DataCenterStrikesBack on Nokia and Kyndryl's LinkedIn, YouTube, or X. And be sure to follow us so that you don't miss our next episode.
Join us next time as we dive further into data center interconnect, its use cases, customer demands, and how a consolidated OTN service architecture could be just the most economically viable thing for multi-stakeholder investments. See you then. Today's episode of the Data Center Strikes Back featured James Knights from Kyndryl Consult and Vittorio Iozzolino from Nokia, and me, your host, Peter Nass from Kyndryl. The Data Center Strikes Back is a joint production by Nokia and Kyndryl.